guys, cloudy here. It's a perfect day for something geek, so let me show you something. Here is a Flyport GPRS. I bet you wonder what you can do with it, seeing it on the store, like, hey, what can I use it for? And today I'm showing you something really cool. So say you're going to get those last feelings for dinner, or you're enjoying your beach time and your dear friends arrive before you're home, so you have to open for him. What can you do? You can use your Flyport to activate the remote control of the gate. For example, like I'm doing here. I'm just calling the Flyport from my mobile phone, and the Flyport will activate the remote control of the gate. And I'll just get in like if I were your friend, and you arrive later, comfy and ready to enjoy your time. Now I'm just going to park my car so I can take my computer and just tell you how I use.
Okay, we are back in the office, and here is how you have to connect all the things together for this project. Here is the Flyport GPRS module, and here is a SIM card. You can use whatever reader you want. SIM card goes on the back side like this. And as you can see, the Flyport GPRS uses both J1 and J2 connectors, so remember to align them correctly on the ground board. J1 on J1 and J2 on J2. Here is the antenna, which is sold separately, so if you need it, remember to buy it. It has a micro UFL connector which goes here on the Flyport GPRS. Then the relay, Grove relay, which goes on digital 2 connector socket here. And to allow easy view of the number and what the Flyport is doing, I'm using an OLED display which is I2C, so it is plugged in the I2C socket here. The programmer, remember to align it correctly with the marks on the board, goes here. And finally the new Grove battery, which has an integrated charger IC, so you can just plug it in here and then just plug a USB power cord or a DC power cord on the Grove or on the programmer, and it is charged automatically. As you can see, the Flyport now is powered on, but the programmer is keeping it in reset. So to show you how this thing works in real time, let me plug it out, and the Flyport will start. You'll see the LEDs will blink to show that it's searching for the network operator, like this, and then you see the init sequence here with the logo. Oops. And now the Flyport is idle. Now I'll bring in my phone, and you see I'll make just a call to the Flyport module, and it will turn on the relay and show the color ID. And as you can see, it works. It also turns off automatically, and when I close the phone call, it will reset itself. Okay, here we are with my computer ready to start showing you the code for the gate opener. Yeah, so first of all, I'm going to show you a flowchart because the code for this follows a few jumps, so this should be quite easy to follow. Here is the flowchart. We have two separate sections, the one on the left and the one on the right. Start from the one on the left. Why I've separated this? Because the Flyport GPRS uses asynchronous events to notify the user of what's happening. In this case, I have an on-ring event and no carrier event. These two events are triggered by the GPRS module, and they tell you on ring event when you're receiving a ring, which happens multiple times when you receive a call. When you are calling someone and you hear the ringing tone, every time you hear the ringtone, an on-ring event is fired by the Flyport. So keep in mind that in a single call you may receive multiple on-ring events fired. So what will I do with the ring event? I will check the caller ID to allow for some numbers to activate the service I want and others to be ignored. So if the check goes through, I will activate the relay and eventually display the caller ID. Now, to reset everything, the only way I have to know the call has ended is the no carrier event, which is triggered just when you hang up. So this will start a global timeout that will reset every variable I've set before. So these two events will effectively set a couple flags which will be used by the main loop, which is here on the right. So for example, when the main loop starts, it checks if the relay is active. This is simplified. We'll see later that the first check is if an event ring, a non-ring event has been fired. Anyway, this is because the relay active is the most important thing. So if the relay is active, next check is if the relay timeout has occurred or not. If it is, I'm going to deactivate the relay and enable the relay activation, so to avoid possible multiple activations following the multiple on-ring event I may receive. So after this, the next check is if the global timeout is occurred. If so, I will re-enable the relay I have previously enabled it. I'll clear the screen and reset the timeout. This is how things work. So now let's get to the IDE and I'll show you how to get this flowchart transformed into code. So let's open a new Rovness GPRS project. Let's call it gate opener and put it in my OpenPicus projects. As you can see, we have two modules, the Flyport, the Task Flyport module and the GSM events module with the on ring, on no carrier, etc. events. So here is where we are triggering, or better, setting the flags that will later be checked in the main cycle. So here I'm going to declare a Boolean variable called detected. Now let's say detected ring equals false, and a string to hold the caller ID, and I'm going to use this here. Detected ring set to true, and caller ID I'm going to sprintf something in it, %s phone number. Now in the main cycle I'll just copy paste some code to cut times a little bit shorter. So let's get rid of the button we're not going to use, and here are the initialization of the relay and the OLED screen with the simple showing of the logo and the welcome GPRS phrase. Now the important things are in here in the main cycle. The first comparison we're going to use is an if detected ring equals true. We're going to do something. So what we are going to do is trigger another variable. First, reset this one because we don't want to run multiple times the same loop. So detected ring equals false. Relay activate equals true. Then maybe some meaningful UART serial message like UART write one receiving call number and UART write one caller ID and a final /n to keep things tidy. Now you may notice we are using caller ID and detected ring, which we don't have here, so we have to declare them external like this. Extern bool detected ring and extern char caller ID. Now, if I did everything correctly, this should compile fine. Okay, the OLED screen, I need the libraries here. Include OLED.h and include logo.h. And now this should compile. Okay, I pasted some code that uses a counter, so I'm going to declare the counter variable here. And we're good, I bet. Oh no. We have declared relay activated here, which I haven't declared before. So relay activate is going to be used in another comparison here, which is relay activate equals true, then relay activate false. What we are going to use this for? We are going to use this to separate the activation and the activation in a way that we can control, because what we want is that the duration of the activation to be definable in the code. So I want, for example, the relay activation to last for 2 seconds, while the call may last for, let's say, 30 seconds, and I don't want the relay to be on for 30 seconds. So I have to separate things more to control them better. So in this instance, I'm going to separate every step of the activation. In this case, I'm going to use also relay activated so that I can do something else when the relay is activated. So now what I'm going to do is add another flag, which is relay timeout, and set it to true, then set my relay on, and if I stop here, what I get is that for every call that arrives, I get the detected ring to become true and the relay to be activated, which is not what I want. So what I'm going to do is put a string comparison here, which is a way to determine if the number of the call I get is the one I want. I may use one or more if I want to allow more numbers to do different or maybe the same thing. And in this case it is string compare caller ID with my number, which I'm going to mask just for privacy purposes. If this string comparison returns true, I'm going to activate the relay. Okay, so if I am the one calling the number in this case, the Flyport, the relay is activated, which means I'm going to set this flag to true, which allows this code to execute, and I still need to turn the relay off. I mean, I need to use the relay timeout. And what is the relay timeout for? It is to avoid reactivating the relay. So I'm going to do a logic AND with relay timeout so that when we are timing out, we can't reactivate the relay even if the detected ring is triggered again. This way I can avoid turning on and on the relay in a loop. So here I'm going to add the relay threshold. So relay threshold equals time get tick get bib 64k plus, let's say, 2 seconds of duration. You may want 1, you may want 5, just change this number, and this is the time the relay will stay active. So the next check is if relay activated, which means we have the relay on, we are going to execute the threshold check. So if relay threshold is lesser than tick get div 64k, then we're going to shut the relay off. So set my relay off and relay activated false, and maybe just add some meaningful messages like your right one deactivating relay, and here activating relay. Now at this point we have the relay activation which is triggered just once per call, but we don't have the reset of the relay. So what we're going to do is use another Boolean variable like bool timeout equal false, and we're going to set it on no carrier event timeout equals true. This way we have a flag that is set when the call ends. This is the event that gets fired when you hang up on the Flyport. So here we're going to use another condition on the timeout, which we're going to act upon later. Now I have to add another extern bool timeout to include the external variable. And I have also to add all the variables I have created in the text. So all the relay activated, the relay timeout, and so on, I have to add them here. So let's start doing this. Bool relay activate equals false. Relay activated equals false. Then I can stop here, guess, and add 2 other integer variables as relay threshold and I forgot relay timeout here. Let's try to compile. And I did a little error. Right. Now closing parent here. And the compilation went through, so I'm okay. So what I have to do on the timeout, this timeout goes pretty much like this part here. I mean, this is the place where we act on the event. It's not something we act directly on. I mean, when we receive the event, we do something which triggers later what we're going to do. So this is pretty much the same. I'm going to set a variable like timeout false, timeout started through, and timeout threshold equals tick get div 64k plus, let's say, 5 seconds in this case. So as you can see, this goes pretty much like this part here, and we have just another part which goes just like this. So if timeout started, if timeout threshold lesser than tick get div 64k, we're going to reset all the flags. So timeout started false and relay timeout false, and also relay activate, because we may be in a situation in which this check prevents us from re-enabling the relay, but this one goes through, so relay activate is through. In this case, we have to reset this here too. So in this code, we have everything we need to turn on the relay for just 2 seconds when we receive a call from a verified number, and wait for the next call before reactivating the relay using this delayed timeout and reset. Let me just pass here the code for the OLED screen so you can see it. One snippet goes here, and another goes here. This is the entire source code you're going to find on the wiki, and we're done. After this, you may compile now. I forgot to add few number of variables really, so I have to do this now. Started timeout started equals false, and here I have to add timeout threshold, and let's see if I forget anything else. Oh yeah, the code I passed used another variable name, so color ID, here it goes. And as always, I spell threshold wrong. I am not native English, so I do this pretty often. Okay, the code's compiled, so you're pretty much good to go. As always, find, as I said, the entire source code on the wiki, and use the form if you have got any problems or want to comment. Follow us on Twitter for updates, and see you next time, guys. Bye.